Have you ever stared up at the night sky, wondering what secrets are hidden in that endless ocean of stars? What if I told you that out there, beyond the twinkling lights we admire, lies some of the strangest, most terrifying, and most fascinating mysteries of the universe? Things so powerful that they can swallow light itself. Invisible forces that shape galaxies, and wandering planets lost in the dark void, drifting endlessly without a sun. Yes, I'm talking about black holes, dark matter, rogue planets, and the bizarre phenomena that remind us just how small we are in this vast cosmos. Let's begin with black holes. Black holes are perhaps the most feared and misunderstood objects in the universe. They're born when massive stars collapse under their own gravity, creating a region of space so dense and so powerful that nothing, not even light, can escape. That boundary is called the event horizon. Once you cross it, there's no turning back. For decades, scientists thought of black holes as cosmic monsters, giant vacuum cleaners sucking everything around them. But here's the truth. Black holes are not roaming the galaxy hunting stars. Instead, they sit quietly, only devouring matter that ventures too close. And yet, their power is beyond imagination. When matter falls into a black hole, it doesn't simply disappear. It gets heated to unimaginable temperatures, spinning around at nearly the speed of light, creating jets of energy that can be seen across galaxies. Some of the brightest objects in the universe, called quasars, are powered by supermassive black holes at the centers of galaxies. But here's the twist. We still don't fully understand what happens inside a black hole. Einstein's theory of general relativity says space and time get infinitely curved. Quantum mechanics says something else entirely. At the core, known as the singularity, our laws of physics simply break down. It's as if the universe is keeping its deepest secret locked away. Now, imagine this. Our Milky Way galaxy itself has a black hole at its center. It's called Sagittarius A*, and it's about 4 million times the mass of the Sun. Don't worry, it's 26,000 light years away. So, we're safe. But the fact that almost every galaxy has one of these giants at its heart tells us that black holes may play a key role in shaping the universe. Still, black holes are only one part of the mystery. Let's talk about something even stranger: dark matter. Dark matter makes up about 27% of the universe, yet we can't see it, touch it, or directly detect it. It doesn't emit light, it doesn't absorb light, and it doesn't reflect light. It's invisible. So how do we know it's there? Because of its gravity. When astronomers look at galaxies, they notice something strange. The stars on the edges orbit way too fast to be held together by just a visible matter we can see. Without some hidden mass, the galaxy should fly apart. That hidden mass is what we call dark matter. It acts like a cosmic glue, holding galaxies together, shaping the large-scale structure of the universe. Imagine a vast invisible web spanning across space, and on that web, galaxies form like dewdrops on a spider's web. That's how dark matter works. But here's the catch. We don't know what it actually is. Some may think it is made of exotic particles we haven't discovered yet. Others suggest it might be linked to unknown forces of nature. For now, dark matter remains one of the greatest unsolved mysteries in science. And then, we have rogue planets. Unlike Earth, Mars, or Jupiter, which orbit around the Sun, rogue planets wander the galaxy without a home star. They drift alone in the dark, cold, and silent. Some were likely kicked out of their solar systems during violent cosmic events. Others may have formed in isolation. Can life exist on such lonely worlds? Surprisingly, maybe yes. If a rogue planet has a thick atmosphere or underground oceans heated by internal energy, life could still survive hidden beneath the surface, away from the frozen wasteland above. Imagine civilizations that evolved in total darkness, never knowing the warmth of a star. The thought itself is mind-blowing. But the cosmos doesn't stop there. We also encounter strange cosmic phenomena that defy imagination, like neutron stars, remnants of collapsed massive stars so dense that a teaspoon of their matter would weigh 1 billion tons. Or gamma ray bursts, powerful explosions that release more energy in a few seconds. than our sun will in its entire 10 billion year lifetime. Or fast radio bursts, mysterious signals from deep space that last only milliseconds, but carry enormous amounts of energy. Each discovery adds more wonder, more questions, and more ado to our understanding of the universe. And with every answer we find, new mysteries open up, reminding us that science is a never-ending journey. So, the next time you look up at the night sky, remember those twinkling stars are just the surface. Behind them lie hidden monsters, invisible matter, lonely wanderers, and powerful cosmic fireworks. The universe is not just vast, it's stranger and more beautiful than we can ever imagine. And this is only the beginning of the story. Now, let's go deeper. Imagine a place where time itself begins to stretch, where gravity becomes so strong that even the laws of physics struggle to keep up. That's what happens near a black hole. If you were to fall toward one, something truly bizarre would happen. From your perspective, you would feel like time was passing normally. But to an outside observer, watching you fall, your time would appear to slow down, almost to a halt, as you approach the event horizon. It's called time dilation, a mind-bending effect predicted by Einstein's theory of relativity. In other words, black holes don't just warp space, they warp time itself. Now imagine what's beyond the event horizon. Do black holes lead to other universes? Could they be portals, gateways to something unimaginable? Some scientists suggest that inside black holes, space and time could fold into something like a wormhole. But there's a catch. The immense gravity would likely tear apart anything that tried to enter. Still, the possibility that black holes connect us to other parts of the cosmos keeps scientists fascinated. And let's not forget, black holes come in different sizes. There are stellar black holes, formed when massive stars collapse. There are intermediate black holes, which are harder to find, but may exist in star clusters. And then there are the true giant supermassive black holes, millions or even billions of times heavier than our sun. These monsters sit at the center of galaxies and may actually control the growth and evolution of those galaxies. In fact, without supermassive black holes, galaxies like the Milky Way might not exist at all. But black holes aren't the only invisible rulers of the cosmos. Remember? Dark matter. While black holes dominate small regions of space, dark matter shapes the universe on the largest scales. It forms invisible halos around galaxies, keeping them together. Without dark matter, the universe would look completely different. But dark matter is not alone in its mystery. There's also something called dark energy. If dark matter pulls things together, dark energy pushes them apart. In the late 1990s, astronomers discovered something shocking. The expansion of the universe is speeding up. Instead of slowing down after the Big Bang, the universe is accelerating outward, as if some unknown force is stretching space itself. That force is what we call dark energy. It makes up nearly 70% of the universe, yet we have no idea what it actually is. Think about it. Almost everything we know, everything we can see, all the stars, planets, and galaxies is only about 5% of the universe. The rest 95% is invisible. Dark matter and dark energy together dominate reality, yet remain hidden from our direct observation. It's like living in a house where 95% of the rooms are locked, and you only get to see a small corner. Now, let's drift away from galaxies and talk about rogue planets again. These mysterious wanderers may actually outnumber the stars in the galaxy. Some estimates suggest there could be billions, maybe even trillions, of rogue planets drifting silently in the Milky Way. Imagine that. For every star you see in the night sky, there could be multiple planets wandering in the dark. Some may be rocky like Earth. Others might be gas giants like Jupiter. But all of them are alone, cut off from the warmth of a parent star. Yet nature finds a way. If a rogue planet has a molten core, it could generate heat for billions of years. If it has a thick atmosphere, that heat could be trapped, keeping subsurface oceans liquid. That means life could be hiding in places we never even considered. Astronomers are now designing telescopes to hunt for these lonely worlds, hoping to catch the faint glow of their heat or the bending of starlight as they pass in front of distant suns. And while rogue planets drift silently, The cosmos around them roars with activity. Let's talk about some of the strangest cosmic phenomena. Take neutron stars. For example, these are the remnants of stars that weren't quite massive enough to become black holes. They're incredibly small, just about 20 kilometers across, but unimaginably dense. 1 teaspoon of neutron star material would weigh about 1 billion tons on Earth. Some neutron stars spin hundreds of times per second, shooting beams of radiation into space like cosmic lighthouses. We call them pulsars, and they're so regular in their timing that scientists once thought they might be signals from aliens. Then there are magnetars, a rare type of neutron star with magnetic fields so strong that they could erase data from a hard drive from halfway across the moon. But even neutron stars pale in comparison to the most powerful explosions in the universe. Gamma bursts. These bursts unleash more energy in a few seconds than the sun will emit in its entire lifetime. Some are caused by massive stars collapsing into black holes. Others may come from neutron star collisions. If one happened close to Earth, it could strip away our atmosphere in an instant. Thankfully, the nearest ones are billions of light years away. Still, just knowing they exist shows us how violent and energetic the universe can be. And then there are fast radio bursts, mysterious, millisecond-long signals that appear from random points in the sky. Some repeat, others don't. Scientists have theories. Maybe they're caused by maybe by colliding stars, or maybe even something we haven't yet imagined. Whatever their origin, they remind us that the universe is filled with surprises waiting to be discovered. The deeper we look into the universe, the more we realize just how strange and mysterious it truly is. Black holes, dark matter, dark energy, rogue planets, neutron stars, gamma-ray bursts. All of these are pieces of a cosmic puzzle we're still struggling to solve. But the mysteries don't end there. Let's step back and think about the universe as a whole. When we look at the night sky, we're not just seeing stars. We're looking back in time. Because light takes time to travel, the stars we see tonight may not even exist anymore. Some of them might have exploded millions of years ago, and yet their light is only reaching us now. The farther we look, the further back in time we see. Telescopes like Hubble and James Webb act like time machines, letting us peer into the universe as it was billions of years ago. And when we look far enough, we see the afterglow of the Big Bang itself, the cosmic microwave background radiation. It's a faint whisper of light, a snapshot of the universe, when it was only 380,000 years old. From that glow, we've learned so much about the universe's birth, its age, and its composition. But one huge question remains. What came before the Big Bang? Did time itself begin there? Or was our universe born from the collapse of another? Some scientists think the Big Bang might just be one cycle in an endless loop of expansion and contraction. Others suggest our universe could be just one bubble in a vast multiverse, an infinite ocean of universes, each with its own laws of physics. If that's true, then everything we know, all the galaxies, stars, and planets, could be just one tiny island in a cosmic archipelago beyond imagination. It's almost impossible to comprehend, but it makes you wonder, what else might be out there? Now, let's bring the focus back closer to home, to our own galaxy, the Milky Way. The Milky Way is massive, about 100,000 light-years across, with hundreds of billions of stars. Yet it's just one of trillions of galaxies in the universe. At its center lies a supermassive black hole called Sagittarius A*, around 4 million times the mass of the Sun. It's surrounded by a dense cluster of stars that orbit at incredible speeds, a cosmic ballet, choreographed by gravity. But the Milky Way won't last forever. Billions of years from now, our galaxy is set to collide with its nearest large neighbor, the Andromeda Galaxy. The two will merge in a slow-motion crash lasting millions of years. Stars will be thrown into new orbits, new stars will be born, and the galaxies will become one giant elliptical galaxy. It sounds terrifying, but in reality, the chances of stars actually colliding are very low, because space is so vast and empty. Instead, the merger will create a new, more massive galaxy, reshaping the night sky forever. And speaking of the night sky, let's not forget how small we really are. Our sun is just one star among billions in the Milky Way. Our planet is just one rock orbiting that star. And yet, on this tiny rock, life has emerged. Conscious beings, capable of thought, curiosity, and imagination, are looking out into the universe and asking big questions. That in itself is one of the greatest cosmic mysteries. Why does the universe produce beings that can reflect on their own existence? We don't know the answer, but the very act of asking makes us unique, and it drives us to explore further. Think about all the tools we've built. The James Webb Space Telescope, peering into the first galaxies. The Large Hadron Collider, smashing particles to unlock the secrets of physics. Gravitational wave detectors, listening to the ripples in space-time from black hole collisions. Each of these discoveries opens a new window into reality. But with every answer we find, new questions appear. For example, gravitational waves proved Einstein right in ways we couldn't imagine. But they also raise new questions about what happens inside black holes. We can detect dark matter's effects, but we still don't know what it's made of. We see the universe expanding, but we don't know why dark energy exists. It's as if the universe is always one step ahead of us, teasing us with clues, but keeping the full picture hidden. And maybe that's the beauty of it. The cosmos is not a puzzle we're meant to solve overnight. It's a story, a never-ending journey of discovery. And we are characters in that story, writing new chapters with every observation, every experiment, and every idea. So we are, standing at the edge of human knowledge, staring into a universe that is both terrifying and beautiful. We've talked about black holes, those cosmic monsters that swallow light and bend time. We've explored dark matter, the invisible glue holding galaxies together. We've touched on dark energy, the mysterious force pushing the universe apart. We've drifted with rogue planets, lonely wanderers lost in the void. We've marveled at neutron stars, magnetars, gamma-ray bursts, and fast radio bursts, cosmic fireworks that remind us how powerful and unpredictable space can be. And we've dared to imagine the multiverse, a reality beyond our own where endless other universes might exist. But perhaps the greatest mystery of all is not out there in the stars, but right here, within us. Because the fact that we can look up, ask questions, and feel wonder is nothing short of extraordinary. The universe is 13.8 billion years old. It has seen stars born and die. Galaxies co-guide and cosmic structures form on unimaginable scales. And yet, out of all that chaos, life emerged on a small blue planet orbiting an average star in a quiet corner of the Milky Way. Think about that for a moment. Atoms forged in the hearts of dying stars came together to create you. Your body, your thoughts, your imagination. All of it is made of stardust. We are not separate from the universe. We are the universe, looking back at itself. That realization is humbling, but also empowering, because it means we belong to the cosmos. We are explorers by nature. We build telescopes, rockets, and satellites, not just because we want answers, but because curiosity is written into our DNA. From the first humans who gazed at the night sky, to the scientists today decoding signals from billions of light years away, we have always been driven to seek, to learn, to understand. And that journey will never end. One day, we may solve the mystery of dark matter. One day, we may understand dark energy. We may discover life on a rogue planet, or in the oceans, beneath the icy crust of moons, like Europa and Enceladus. We may even travel beyond our solar system, becoming wanderers among the stars. But, Evan, then new questions will arise, because the universe is endless, and its wonders are infinite. And maybe that's the point. Maybe the universe was never meant to be solved like a math problem. Maybe it was meant to be experienced, to inspire, or to spark imagination, to remind us of how small we are, and yet how connected we are to everything. So the next time you look up at the night sky, remember every star you see is part of a story billions of years old. Every photon of light has traveled unimaginable distances just to reach your eyes. And hidden beyond those stars are black holes, rogue planets, dark matter, and cosmic mysteries, still waiting to be uncovered. The universe is vast. It is mysterious. It is beyond comprehension, but it is also ours to explore. And as long as we keep asking questions, as long as we keep searching, we remain part of the greatest adventure ever written. The story of the cosmos itself. So keep looking up, keep wondering, keep dreaming, because the universe is not done revealing its secrets, and neither are we.